You guys want to take your seats? We're going to get started. All right, welcome, welcome, guys. So excited to see you all. A lot of familiar faces in the crowd. For those of you guys who don't know me, my name's Jane Fang, and I run our developer ecosystem team. And you might be like, what is that? What do we do? It's very exciting. The developer ecosystem team basically sits in the core product and engineering team for mixed reality and AI. And our goal is really to scale developer engagement through the Microsoft machine. So think our field, our sales, our DevRel team, a lot of the fine folks who are actually here with us tonight. A core part of that strategy is having a strategic hub here in the Bay Area. So this Microsoft reactor space where we have our San Francisco Academy team. So actually, this is a great moment. If you're with Microsoft, can you just stand up and wave so people know who to network with if they are interested in learning more? We have Joe, Dan, and Nick, who are part of the Academy team. We have Aishagul, who's our Cloud Advocate team. We have Linda, who's with our Worldwide Developer Ecosystem team. Samira's here. I just saw her from our Fluent Design team. John in the back, who works on our Mixed Reality Partner Program. Lots of fun people who are here tonight to spend time with you guys. But I'm here to introduce our special guests. And when this guy shot me an email about a month ago and was like, hey, I've heard that you're doing some pretty cool stuff in San Francisco. I kind of want to make a trip. I was like, heck yes. Like, this is amazing. So tonight's presentation is all about HoloLens 2 and creating HoloLens 2 from someone who should know a thing or two about HoloLens 2. So our special guest flew down from Redmond, and he is responsible for the product decisions and coordinating across software, hardware, go-to-market teams, and the HoloLens product roadmap. So tonight, he's going to get nitty-gritty about HoloLens 2, give us some insights on design choices that were made, and talk about some exciting features. After his presentation, he's going to have some question and answer time. And then after that, we're going to all mingle and talk about mixed reality and break out into networking time. So with that, I'd love to welcome Charlie Hahn to the stage.
Good? All right. I'm just going to leave this here. First off, thanks everyone for joining us here today. I'm really excited to spend a little bit of time with you to talk about HoloLens 2, especially in terms of both the design decisions that we made to create HoloLens 2, but give you a little bit of insight into really where we're going with this technology. Maybe first things first, just a little bit of background about myself. I've been on the HoloLens team for about 5.5 years now. I started around the time that the first generation product was just formulating and getting into shape. Back then I worked on the Core SoC platform, Core OS pieces, but I had this deep burning desire to not just contribute technically to the project, but to understand what customers and partners and developers like many of you really wanted to see us grow in terms of the mixed reality futures. And so after the first generation largely wrapped up, I went to my manager and I said, hey, you know what? We don't really have this notion of product management at Microsoft, but I think that's really the thing that we need. I want to go and figure out how we go and build the right things into the future for all of our customers and partners. And so I said, yeah, that makes sense. Why don't you go and drive that effort for us on our HoloLens futures? And so since that time, it's been 2.5, maybe 3 years ago, I've been spending a lot of time talking with customers and partners and developers to really understand, what do they love about HoloLens as it exists? What do they want to see more of into the future? And what our journey is to go from here to there. Now, I want to, just say a couple things in terms of this particular device itself. Now, the team, we're all incredibly proud of the work that we've done, but we know that this is a journey, right? This is not the end. This is really still just step 2. It's beginning. And what I hope that you take away from today is not necessarily the specific feedback or feature I told them about didn't make it or did make it, but rather to think through what the journey looks like. And are we hearing at least the right trends and directions that you guys are providing to us? That's really the thing that I would love to, talk to you guys later about, in terms of what you see in the product, what I'm going to talk about, how we make design choices, the principles that we use to drive this technology forward. And for HoloLens, it's really about not just driving a first-party product or device forward, but also an entire ecosystem, right? An ecosystem of mixed reality, be it first-party devices, third-party devices. First-party solutions, third-party solutions. All of these things are so incredibly important to us and are fundamental for us to be globally successful at driving mixed reality as an integrated effort across the board. Okay, so enough preamble. I think things are good? Okay. So I don't know about you guys, but I've seen that video, I don't know, infinite times now in preparing for the keynote and the announce and everything. But I still get goosebumps watching that video because I think there's a couple things that actually give me goosebumps. The first one is that everything that you saw in there, some of the mechanical designs of the product, those are all actually real. This isn't like something we invented for a cool video, right? Like this is the technology that makes a device like this possible. It gives me goosebumps because it's actually kind of like science fiction that we're able to bring into product. Second thing is, when you look across the types of customers that we have, it actually does span a wide range of, commercial customers, from different industries. But I also want to point out that last little snippet there. We really look at this as a sort of a creative outlet, something that we haven't been able to, experience before in the form that we're trying to go and bring to market. And that's the thing that I think, especially for a lot of the folks in this room, you guys are the visionaries, the people who are looking at what's the next thing. Maybe not the thing right this moment that has mass adoption, but you're the fortune tellers, the people who are trying to create that future. And that's a really important part of what we do. Let's be clear, when we started this project many, many years ago, we were much in the same boat. And so for us, it's really close to our hearts to be able to work and speak with people like you and support people like you. And that is key and important. When you guys are trying to create a business, trying to create a living out of this effort, trying to create a future together, this is the thing that we're really doing and building this stuff for. So thank you from the bottom of the entire, the hearts of the entire team in the HoloLens group. We really do thank you and appreciate your support here. I asked a few people around the room before I started this presentation to just get an understanding of, how much, how many people had watched the keynote, how many people had seen the highlights, read articles. And for the most part, what I saw was that generally people kind of already have seen the key attributes of HoloLens 2. So I'm not going to spend a whole lot of time dwelling on these, but I think it is important because talk about these, not because necessarily to tell you the specific, precise features, and I'll talk about a few of them in some of the design decisions that we made, but I put these up because these are long-standing, durable pillars that the team operates by. As I mentioned at the very beginning, this is a journey for us, right? This is not the end. This is the beginning. And so as you think about, hey, what is our next product going to look like? It's going to be more immersive. It's going to be more comfortable. It's going to be more value. What about the generation after that? It's going to be even more immersive, even more comfortable, and even more valuable. And particularly on the time to value piece, especially for the folks in this room that are developers, that time to value is about the solutions that you're building for the customers that want to use this product but don't necessarily have the capability to develop something themselves. That's the part where time and time again we've heard feedback from the industry just to say, hey, I don't have the expertise to go develop these solutions. I am here to go and drive forward productivity in my workforce, or I want to experience something completely new. I want to give a new experience to my customers, but I don't have that technical expertise to go do that myself. Can you help us? It's the folks in this room that we're looking to help those types of customers. So now that I've given you the roadmap of all of the things that we're going to invest in for the next multiple generations on end, I do want to talk through a few particular sort of principles around how we make trade-offs amongst these things. So I want to start first with this notion of these three pillars. So roughly speaking, if you plot these three pillars as a chart, let's say you start here. You've made some trade-off between the comfort of the device, the value of the device, the immersion of the device. Technology and physics is kind of like finite, right? So it's actually relatively trivial to go push in one particular direction. I'll give you an example here. When we were designing the product initially, and we were looking at, okay, great, we have the field of view that we do in HoloLens 1. How do I grow the field of view of the next product? It's actually quite trivial to grow the field of view. Just make a bigger display. But that doesn't do a whole lot good from a comfort perspective. It might actually cost you a lot more money as well. And so for us, it's not about pushing in one direction or another. By the way, some customers, some partners told us, the only thing I care about is immersion. I want you to grow the field of view at the cost of all else. But then you talk to a different customer, and they're like, well, actually, the field of view is okay, but I want to be able to wear it for longer periods of time. Then you talk to yet another third customer, and they'll tell you, actually, none of that actually matters. All I want is the solution that integrates into my workflow. And so it is truly about balancing all of these that is critically important. Keeping the area under the triangle roughly constant is not that hard. It's about what do you need to do in order to actually grow the area under that triangle, to be able to take that generational leap time and time again. When I joined the team, it was when HoloLens was extremely secretive. We didn't publicize it. Even internally at Microsoft, it's called this thing called a tented project, which means that even people at Microsoft don't know about the project. And when I was looking for my next gig, 5.5 years ago or so, one of the people that I'd worked with very closely in my previous job had moved over to this team. At the time, it wasn't called the HoloLens team. Obviously, it had like a fancy code name and everything. And he said, hey, you should totally come over and you should come talk to us about a potential opportunity on this team. And I said, okay, that's great. I would love to meet with some of the folks on the team and find out what you're doing. I met with 5, 6, 7 people, and every single one of them said, I'm not going to tell you what we work on. I'm not going to tell you what you're going to work on. But this is the team that you join to create something that you thought was impossible to start the change of the future of computing. And I thought that was fascinating because basically they were like, yeah, you should come join this team that you have no idea what they do, and you have no idea what you're going to do, and you have no idea what the future of this team actually looks like. But they were looking for the types of folks who were in it to go and change an industry. And they were not looking for a particular person who was looking to create an AR headset. They were looking for the type of personality and the type of the teamness that was willing to go jump off a cliff without having a parachute on to build the parachute while midair, right? That was actually one of the quotes that Alex really liked to use, which is like, hey, as a team, we can go do this. We can do it together, but you have to be willing to make that initial leap. Because if somebody told you that, that many years ago that somebody was going to go build an AR headset that could world lock a hologram in space arbitrarily without fiducials or markers, you probably would have been like, yeah, cool, buddy, that's funny. I'm going to go work on like Office or Windows or something like that. But it's really this mentality, the team that's been assembled, that we drive forward to make sure that we can go and expand the area under the triangle time and time and time again, right? It is not enough to move one piece or another. It's got to be the entire thing. When we started HoloLens 1, it looked a lot like this. I want to talk to you about how we didn't just think about, let me just grow the device a little bit and add the features that people want. We were not scared to go and rethink what is the right design decision time and time again. It was fairly monolithic. There was a headband in the middle, but everything else was, largely contained in this sort of monolithic shell. And we realized that as we wanted to grow the capabilities of the device gets constantly more front-heavy, more front-heavy, more front-heavy. And in our comfort studies and our evaluations, we realized that just as important as the size and weight of the device was the actual balance of the device in your head. So if any of you guys ride motorcycles and you wear a big, 1 kilogram heavy helmet, you can actually wear that for quite a long period of time. It's nicely padded, it's nicely balanced, doesn't cause you to, feel like your head's particularly heavy. And we used a lot of the human factors research that went into all sorts of different other industries of how they built headgear to go and rethink, what should this actually look like? And we came up with this, right? We came up with an architecture that was, instead of largely monolithic, which made, cabling and routing and power delivery relatively straightforward, to something that is actually really largely 2 components. The front island, as we call it, that houses only the necessary things that are there. So, for example, the display, the optics, the sensors, and the compute that's necessary to power that. And we moved everything else to the back of the device. Now, this presented incredibly challenging issues with, say, for example, being able to route all of the design, cabling, high-speed interconnects, and power front and back, while putting it into a flexible fit system, while allowing it to expand and contract to fit all sorts of head sizes. But the team wasn't fazed by that. And that's sort of the constant theme that comes back time and time again. We know what the right thing to do is. You just got to push the limits of technology for us to be able to get there. Speaking of pushing the limits of technology, one thing we realized was as we expanded the size of the FOV, expanded the resolution of the displays, it wasn't enough to just take an existing 2D panel and just grow it time and time again. We found that as we designed the optics, it wasn't even a linear system. It was actually an exponential system in order to create the optics for the displays themselves. And so we said, you know what? That's fine. We'll just create a new type of display technology and fit it inside a device that it's never gone before. We created what we call a MEMS laser scanning display. And so this thing has, a set of mirrors, 1 horizontal, 1 vertical for each eye, and it takes the laser light output and it basically spreads it into a 2D surface that looks very much like to you and I, like a 2D display, but actually its only footprint is a set of laser light emitting diodes and a couple mirrors and relay mirrors in between to focus the light. Not only does this give us something that can, dramatically increase the FOV for this generation of products, so over 2 times the FOV field of view compared to the first generation, but allowing us to also present that, larger field of view with an extremely high resolution image as well. So we've actually maintained the angular resolution of the display while growing the display over 2x. So that means that the resolution per eye has actually also increased over 2x generation over generation as well. And in order to actually drive that, in order to actually drive the capabilities, the number of pixels, the reprojection for those displays, we had to create a custom piece of silicon. In generation 1, we had custom silicon to go and process sensor algorithms, run what we called planar late-stage reprojection, where you stabilize one plane of content in the world with the last moment head pose. We realized that in order to stabilize a much larger field of view where you see many more holograms at different depths, in order to enable us to drive higher resolution sensors so that you can get higher fidelity mapping of the world as well as your own inputs, in order for us to be able to better process audio in spatial form while doing it at extremely low power, to do all of this in a device that's passively cooled, required us to take the next leap, the next generation of the holographic processing unit. It's custom designed in-house at Microsoft. We have a team of silicon experts that actually designed this chip. It has a display accelerator, so that late-stage reprojection that I talked about, we actually now use a full depth map of your rendered field so that you no longer have to, as a developer, pick a particular plane and stabilize only that plane. We'll actually automatically stabilize the entire depth map of your rendered scene. There is a native deep neural network implementation. This is a thing that allows us to build models so that you can do some of the things I'll talk about later around hand interaction and articulation of the hands. Not just a learned model or a tagged model that we try to match, but rather truly understanding that this is a hand and it has joints and tips and points so that we can give you arbitrary control, arbitrary power to go create the applications, the interaction models that you want. Being able to offload spatial audio at something that's like 20% of the power that it would take on a general purpose CPU. Vision processing, moving forward all of our algorithms for head tracking, for 6-DoF spatial tracking. Being able to do hand tracking both on the deep neural network as well as in terms of actually segmenting a scene and understanding where hands are in a particular region of interest. And then lastly, adding eye tracking to the device. Now, eye tracking is fascinating because it's the thing that allows us to actually close the loop between the wearer and the actual device itself. So in generation 1, you put the device on, you did your little finger dance when you did your UBI experience, and you got a plus minus few millimeters of your IPD. Modulo somebody actually putting up a set of calipers and measuring the distance between your eyes, that was pretty state of the art, and it was good enough for a lot of the experiences we were creating. But at the end of the day, we didn't know whether you wore the device slightly askew, slightly high, crooked, whatever it might be. And so to be able to produce the most locked, stable holograms in the world, we want to know where you're actually looking through the eye box of the device. And so with eye tracking, we can finally close that loop. We know exactly where your eyes are. And this isn't just a static capability. Because we run eye tracking in real time, we can actually see where your 3D eye position is at any point. So of course, we can close the loop in terms of what we display, but we can now also understand where you might be looking. So no more using your head as a giant mouse cursor. You can use your eyes as well. This is kind of what it looks like if you blow it all out. As I mentioned, there's a front island where we house a lot of the let's call it the specific IP as it relates to a hologram and world locking a hologram, understanding the world, understanding you as a human being. And on the back of the device is where we've housed, roughly speaking, a tablet computer. All of this is brought together into one product. It's passively cooled. It's self-contained. It doesn't rely on anything else to function. And we're pretty proud of what the team was able to accomplish. But in addition to that, it wasn't enough to go build this thing for the one human being that could wear this and put it on their head. As I mentioned, some of the challenges that we had was actually accommodating and building an inclusive design device, right? Whether you wear glasses, you don't wear glasses. Male, female, different ethnicities. We've measured hundreds, thousands of people's heads. This is a short video, a montage of what we call the head scanning capture rig. And so we put people through this. We take, I think they had something like 60 or 70 DSLRs in there. We capture the head. We recompose the shape of the head, and we use those all as models in our statistical design of the brow pad, the back of the device, how it fits on the head. One story that I like to tell on this one is that when we first designed the brow pad, the brow pad is roughly a rigid body with some foam around it so that it keeps comfortable on the head. When we first designed it and we tried it on a bunch of different people, we realized that we saw pressure points specifically on East Asian heads. As it turns out, all of our heads are shaped a little bit different. Our genealogies mean that different ethnicities tend towards different shaped heads. And so like for me, I have a fairly wide brow. And so what we saw was that when we had created this original foam and design for the pad, that for East Asians, it kind of put additional pressure right above the temple, sort of towards the brow of the head. The team leaned in, ran a bunch of statistical models against all of the head shapes that we had, and they actually created a brow pad. The type of foam, the compression pressure of the foam, all of those things so that it could accommodate all manners of different people's heads, shape, sizes. And when we modeled this, it was a fascinating design discussion because they showed the slope of the brow pad that had existed when we had first created the prototype to where we actually got it to afterwards. And you could see that it was a minute difference, but it was about the curvature of that brow pad, the type of foam and the compression values that we put in the foam or the brow pad so that it could work and be comfortable for every single one of us. That's incredibly important. It's the way that we think about design at Microsoft. And in addition to just the brow pad, obviously making sure that it actually fits a wide variety of human head shapes, sizes. This thing, as I mentioned, was pretty complicated because we have a ton of high-speed signals and data processing and power delivery running back and forth through this flexible fit system. Yet you can go and expand and contract this fit system quite extensively. Like I'll show you. Your head can be this big, or your head can be this big. And by the way, our heads do range in size from small to large like that. This is a product where you can wear it over glasses, male, female, different ethnicities, different head sizes. It's incredibly important when we talk to our customers about how they actually see these devices used, right? Whether you're on a construction site and you need to share this amongst workers, whether you're in a museum and you want all different sorts of people to be able to wear it, it was really important for us to go design something that could actually cross the gamut of all of that population and support them with one device. Now, I've talked a lot about immersion. I've talked a lot about comfort. I do want to spend a few moments about that time to value. So now I know some of you that I've talked to in the room are developers. Some of you even have projects in flight where you're serving a particular customer set. We want to support you. We want to support you both in terms of helping you make a business out of this ecosystem, but also giving you the tools to be able to do so with maximum efficiency. And so when we first started this project in HoloLens, the first generation, for the most part, we supported Unity. Obviously, you could develop a native application as well. But as the ecosystem has matured, we realized a few things. Number one, not everyone's a Unity developer. Great. We will continue to support Unity, but we want to add additional middleware, popular middleware in the ecosystem. So with HoloLens 2, we will support Unreal Engine as well. But beyond that, say, for example, you're a native developer. As I mentioned, we care a lot about first party and third party. We are not wedded to this notion that this device is the end all be all. We know that the democratization of mixed reality can take multiple different paths, and depending on the industry, the customer you serve, you need the right tool for the job, and we don't want to lock you in. And so Microsoft joined the Kronos group as a contributor, and in particular, more so, we're a part of the OpenXR group, where we've actually contributed a ton of the learnings that we gained from building HoloLens 1 be it the actual spatial mapping capabilities, be it the understanding of world anchors, the interaction models. We learned a lot. We didn't get it perfect in the first generation, but we learned, and we wanted to contribute a lot of that back into the ecosystem so that everyone could benefit. Because at the end of the day, we think about it as growing the overall mixed reality pie for everyone, and that's the thing that we're really in it to go and drive forward. The third thing that we also heard from developers was, in the first generation, was, great, you've built a pretty cool product. You've even really thought through the design affordances for what it means to create a spatial experience, but now I have to go and recreate all of those elements myself. I feel like you haven't taken those learnings, those capabilities, be it buttons, be it interaction models, and given them to me so that I don't have to reinvent the wheel, right? The IP, the value you bring to your business isn't about recreating how a button should look, right? It's about delivering value to that customer. And you know what? If we're going to go create a consolidated, known experience across all sorts of different solutions, then we should be able to provide the fundamental building blocks. And so we've spent a lot of time and energy investing in the mixed reality toolkit, as well as the mixed reality design labs about creating user experience design and controls so that you can just pick those up and start using them in your solutions right away. One of the principles that we have in the team for this generation is that anything that you see in the core user experience, the shell of the product, should have a replica in this mixed reality toolkit. And because it's an open source project for anyone to contribute to, we expect that this toolkit will vastly exceed the capabilities of even what we put into the core design UX of the product in time. So you can go on to you can go look up the Mixed Reality Toolkit right now. We've actually just released release candidate 1 of the V2 Mixed Reality Toolkit, and you'll see a lot of the affordances that we've added in terms of interaction model, new UI controls into the Mixed Reality Toolkit. So I hope you guys take a look at that. You should give us feedback through those channels as well on anything that you wish that you could do with it. Okay, so I've talked a lot about backwards-facing, backwards-looking things, although you can't actually, this isn't even yet in the market. I feel like it's backwards-looking because we've spent quite a long time on it, but I want to actually spend some time looking forward. So I said today I really want you guys to understand some of the design trade-offs, some of the design principles we used when building a product like this, but I also wanted you guys to understand where we're going, what our future looks like. And so I'm going to lay bare what that does look like. The first thing is, when we think about mixed reality, the first thing we might think about is the output, right? The output being, hey, can I see a digital object in the world as though it were real? That is an important part of it. But the next frontier is really going to be about how do we interact and interface with these digital objects as though they were real objects, right? It's critically important from a mixed reality perspective to enable you to interact with that digital object just as you would interact with the real one. And so some of the affordances we're providing, for example, in hand tracking, giving you 25 different points and joints on the hand as well as palm direction, is all about enabling you to create the experiences, create the interactions to feel real, to be able to pick up a hologram as though it were a real object. That really is fundamentally what we're trying to do here. Giving you a window into the mind with eye tracking. From a human cognitive perception perspective, your eyes dart all over the place. Your eyes give us an understanding of what's interesting to you, what might be surprising to you. It gives us a lot of insight into what you care about. And so think about using this kind of affordance to better tailor your application. Maybe it's not even a UI design control. It's not about targeting something with your eyes as a cursor, but rather, hey, where does somebody fixate in your application? Is there something interesting about a particular component of your application that draws a person's attention in particular? It could be a debug tool for you. And then when we think about the world-leading 6 degree of freedom spatial tracking, we We think about taking that from a relatively local vicinity of being able to place something, say, for example, in this room or this space, to actually extending it out to building scale, to world scale. This is actually a scan that we took by just walking a bunch of HoloLens devices throughout this building. This building is where I work. And if you look at it, these are all feature points that the HoloLens has detected in this building. Now, this wasn't just one HoloLens that built this map. Now, that's the really important part. This map was generated with the help of a new service that we just released called Azure Spatial Anchors. This is the thing that allows us to actually merge maps together for the feature points and the understanding of one device to translate to another via this cloud service, to enable us to do things like loop closures amongst multiple different devices, even though they only have partial maps. If you look in detail on this, the level of fidelity that we're able to get with something like this is pretty insane. Like, you see the shape of the stairwell. That's like a fire exit on the side of the building. As it pans towards the middle atrium here, you'll see the shape of stairs that lead us up to, all of our different floors. And not only does this work on HoloLens, this also works on iOS and Android devices that support ARKit and ARCore. Going back to the right tool for the job, we want you guys to be able to use these capabilities to democratize mixed reality to a larger audience. And fundamentally, everything that I'm showing you here is this progression from going from this notion of sensing the world, sensing the human, to understanding. It's about going from, in the HoloLens first generation, I could target with my head. I had known and learned hand gestures. I could map the space. I had predefined voice commands. And I could use a password or a PIN to authenticate with the device. So really understanding, so that I get not just head targeting, but intent. Are you paying attention more to a particular space, to a particular area? What does that tell you in terms of what you should maybe show to that user? Full articulation and direct manipulation from just knowing and understanding a particular learned gesture, that's giving you the affordance to go and create wondrous types of interaction models with the product. Going from spatial mapping to environment understanding, fusing together a bunch of the services that we have in terms of the cognitive services for custom vision, to be able to do some of this even on device, to understand spaces, walls, floors, ceilings. Moving from just known speech commands to natural language and intent. And going from pins and passwords to biometrics with Windows Hello and iris authentication. This is really how we think about the progression from sensing to understanding to giving you more power and capability to represent something as faithfully as possible to your users. This isn't the end. We still have a long way to go. A lot of what we're talking about here are made possible by cloud services. So the devices I mentioned is passively cooled, has a limited thermal envelope as any passively cooled device might have. And so we think about, hey, as we move from more sensing to understanding, how do we go and add more power? How do we add more information? How do we add more cognition to the device? And so if you look at the local system that exists on the device, you care an extraordinary amount about the latency that's local to the system. So for example, hey, you know what? If I didn't get single-digit millisecond motion to photon latency for my displays, you get really swimmy holograms. That's no good for making something feel real. That's no good when it comes to vestibular comfort. And so you do need this tight loop at the edge. You do need the capability. That's why we built custom silicon to do this at lowest latency, at lowest power. But then you say, there are certain tasks where I don't necessarily need single-digit millisecond understanding. It's okay if I took 3 seconds, 5 seconds to look around this room and understand what kind of room this is. What are the elements in the room? To understand the humans in this room. I have the capability to go and round trip that through the cloud easily and be able to get that back as cognition on the device. You might have heard Microsoft talk a lot about the intelligent cloud and the intelligent edge recently. And when you think about mixed reality and how we view this going into the future, we really do think about it as the intelligent cloud, where we have this cognition, this higher order capability to understand, and the intelligent edge, which is more about giving you the capability to sense the world in real time. So, if the next time somebody asks you, hey, what is the intelligent edge, intelligent cloud thing? You can tell them the mixed reality example of how these things come together to form that worldview. And that is truly how we think about it. How do we decide what do we put on device versus what do we put into cloud services? We really think about, hey, is latency important? Is cognition important? How do we make those trade-offs? As an app developer, in many ways, you're probably thinking about the same. When do I have compute at the edge? When do I put services and knowledge and understanding in a cloud service? And that allows us to go from our current state of largely single user experiences. A gentleman earlier today had come up to me and asked about, hey, does HoloLens 2 enable you to have multi-person experiences? Well, this isn't even just about HoloLens 2 enabling multi-person experiences. This is about a set of services that go cross-platform from HoloLens 1 to HoloLens 2 to iOS to Android devices to bring people together in these shared experiences. Enables us to go from room scale to world scale. I showed you just a brief example of that in the building that I work in. And allows us to go from local experiences, something that you have to update on the device and keep updated on your device and data on your device, to a cloud-based experience, which I think many of you are actually already cloud first today, so that should be nothing new. So the thing I want to leave you guys with here today is that we're on a journey together of moving the mixed reality ecosystem forward. You guys are all here because you care and love this ecosystem, and we want to be there to support you. I spent a lot of time talking with customers and developers about understanding what it is that they want in order to move things forward. And we always want to move faster, and we'll continue making innovations in this area. The thing that helps us immensely is the focus, the energy that you guys can provide to us by telling us what it is that you need to make your next leap forward. And for us to make those design decisions and trade-offs using the principles that I outlined here about immersion, comfort, value, about edge versus cloud, to help paint for you guys the direction that we're going, and for you guys to influence specifically where we make those investments. I just want to say thank you for listening and being such an attentive audience. I think that this is the time to just take a few questions.
Q&A. If you want to ask a question, can you wait for me to bring the mic over?
Can we try it?
So just for the sake of being fair and equitable to everyone, I wasn't going to actually have every single one of you demo it today. I'm happy to walk around with the device and show it to you. I'll turn it on, and you can take a brief glance, but yeah.
So I do AR applications. I'm very excited to work on this device, but the problem is that, excuse me, if it is not ready for the market, then why should I spend $3,500 to build something, for this, spend time and energy and money when I don't know if it will make it to the consumer market? Can you talk about that? Like, what's the price point? What is the timeline for that?
Yeah, I'll start by saying in the relatively near term, I think we tend to over-predict, I guess is the way to say it, as in, hey, we think that advancement's going to come much quicker than it actually does. Let's talk about self-driving cars. Oh my God, for how many years have we talked about self-driving cars are going to be there? But actually in the long term, let's talk about consumer AR. In the long term, we tend to under-predict, as in, hey, who knew that 1 in every 6 people on planet Earth are buying new smartphones every single year, just a few years after we saw the democratization of those types of technologies. I'm not actually going to try to predict for you when it reaches XYZ price or ABC size. I do believe in it, though. It's why I work on the team, why a lot of us work on this team, and that is the future that we're driving to. But at the same time, we need to be realistic and pragmatic about what its utilities and uses are today. You know, when we built HoloLens 1, we had a sense that it was going to be valuable in the commercial space, in the enterprise market, but we did launch it as a development kit. I think we were given that feedback in the ecosystem that, yeah, in fact, this is where it sees value today. Even at its price point, even where it is in terms of form factor, it has tremendous value. It's actually extraordinarily easy from an ROI perspective for a number of these use cases and scenarios to be proven out on a device like this. And we continue to see that today. At the price point, the form factor, the capabilities it has, we've seen actually an incredible amount of customer feedback and positive reception and an order book that backs that up. But is it the consumer device that you want to wear that looks like my glasses here? No, it's not there yet, obviously, right? If I had that, then I wouldn't show you this. I would show you, oh, actually, oh, yeah. But we're going to get there. But as you guys think through what you develop, why you develop, and who your customers are, I mean, I think we all have to be a little bit pragmatic about who is going to use it today. Yet at the same time, I just visited a partner here locally in San Francisco earlier today, and I saw what was this sort of the state of the art, state of the possible. It was an experience where I walked through essentially a self-guided tour, a curated tour of digital art installations, right? You can imagine a future where, you know, you could have a museum anywhere you wanted of any genre that you wanted instantaneously. People are doing that today. They're doing it with a business model and a set of experiences that make sense for today as well. And so I want to dream with you as well about that, you know, future point where everyone has AR glasses and there's infinite content available for them. But as you think about the products and the solutions you're building today, just like if we do, think about the customer market fit of what makes sense right now based on what's available. And by the way, I'll tell you, there's no shortage of opportunity even there.
Hey, I was very excited that you mentioned latency and the related subjects, but do you guys currently know what your process is for lowering web latency to the device for things like spatialized web, things like you just mentioned, tours around a city or stuff like that, that will use data pulled from the cloud? Have you guys worked more on the built-in version of the browser to lower the latency to be competitive with upcoming systems like Google's Project Stadia and stuff like that?
Yeah, it's a great question. There are a couple of things that I can comment about there. First off, obviously on the system itself, we spend a lot of time in the core OS, so it's not even just the, let's say, the web browser itself, but say, for example, the rendering engine that underlines it. We spend a lot of time there optimizing and tweaking, making sure that we squeeze all of the latency we can out of the render pipeline. But the other thing that we do on the device, and I mentioned briefly as part of the custom silicon, is that no matter what we're talking about here, and maybe 5G will show up and save the world with single-digit millisecond, you know, latencies, and you know, all will be great, is that we know that for a long period of time, we are going to continue to have some latency at the edge. And so we've built late-stage reprojection into silicon so that we can reproject based on latest head post. So it's okay if you sustain tens of milliseconds of latency, as long as I can reproject with the most accurate head post just a few single-digit milliseconds beforehand, you can accommodate for a lot of it. You know, if you understand this technology in space around how, you know, head pose and reprojection can work, you know that it's not perfect. But we can hide a lot of that latency, and that's actually one of the core fundamental things that we think we are going to need to use for quite some period of time, because at the end of the day, whether you're rendering something on the device, whether you've rendered it somewhere else, like, you know, Stadia, for example, there is still going to be that render latency, that network latency that comes down to the device, and we believe that in order to get to the most stable holograms, the most stable experiences, you are still going to need to do some amount of reprojection at that edge.
The next question over here.
First of all, can you hear me?
Yeah.
Okay. First of all, great talk. Thanks for walking us through all this. I had a specific question about the neural network acceleration and for, for capabilities like you mentioned, natural language processing, running custom models for image detection and so forth. Obviously, Microsoft offers pretty robust services through the cloud, but there are lots of applications where you want that constrained locally. You don't want to be sending data perhaps for privacy reasons or performance reasons, or you just want to have it untethered to any sort of network. Are you able to today speak a little bit about what might be possible for developers to access on the device itself versus cloud, and if so, how, for example, like the neural engine acceleration compares to commercial products right now, like for example from Apple on the new iPhones and so forth. So I was wondering if you can kind of give a little bit more insight onto those aspects.
Yeah, so because of the sort of the design considerations and design constraints of a passively cooled device, we've been very particular about the sets of algorithms that actually run on that holographic processing unit in particular. And so at this point, we have not created an open development model for that platform, but this is an area that we continue to explore and wanting feedback from the ecosystem about what makes sense to do at the edge. A lot of what, for example, Azure, some of those services that you mentioned, they do provide containerized versions that you can go deploy on edge devices. And that's an area, again, as well, that we continue to explore to figure out what makes sense to run locally on the device. I will say that the contention point, especially in the holographic processing unit, is that there are certain things, as we talked about, for example, like late stage reprojection or head poses, that are extremely latency sensitive. And we want to make sure that, when we open up a platform like that, that we still guarantee and maintain those core capabilities so that somebody isn't writing an algorithm that says, great, I can process the entirety of this room, but now all of my holograms got extremely jittery. And so those are the design trade-offs. Those are the design, both from a compute, but as well as development platform and isolation perspective, we're still thinking through.
Yeah, I was just wondering, in the same way that there's now a toolkit of UX items for people interested in designing for this, is there any sort of repository or plans to make one for sort of case studies that prove out the ROI you were speaking to for potential skeptics or stakeholders?
Yeah, so there are a couple things. Number one of the things that we've seen as the most valuable set of proof cases is not actually necessarily creating a sample that shows some particular business value. It's actually being able to point at specific true deployment cases. Actually, one of the things that we learned as part of the Generation 1 learnings was that, initially when it was just sort of the Wild West and everyone did, as they did, and we were sort of still searching for signal and seeing where that value was coming from, everyone created a pilot, a proof of concept. They created a sample application. It didn't tie into data backend systems. It didn't actually meet the specific workflows of a particular customer, but damn, it was a really nice demo, right? And what we realized was that, hey, in order to actually prove that value, it wasn't enough to wow that incubation team who was interested in picking up a few devices or a demo solution. It was really about building the true end-to-end solution, all the way back to the business data that powers these businesses. And so what we see today is that in order to really drive the business value conversation, we see it more valuable to go create case studies around businesses, customers that have truly deployed end-to-end, the productivity gains that they're seeing, the value that they're achieving. Those are the case studies that we're really focused on developing and delivering in conjunction with partners, by the way, who are actually completing that last mile. That last mile is so critical to that value equation. And so that's sort of the mentality that we have when we approach that business value conversation.
Hi, I'm James Adams with VisionLib, which is an SDK for tracking and augmenting 3D objects based on a CAD model.
Cool.
So we primarily work with manufacturers or customers of manufacturers. My question is, currently our SDK works on the CPU.
Okay.
But with Snapdragon 850, I know you got a DSP, you got a GPU. Just wondering if you have developer recommendations for how to basically which processor, which compute to use. Do you have something like Qualcomm Symphony project where it'll load balance across the three dynamically, that sort of thing?
Oh man, you're definitely getting out of my realm of comfort on that one. How about we take that one as a follow-up specifically, and I would love for the team to get back to you on sort of best practices on that one.
Hi. In your opinion or your vision, do you see this as a kind of a standalone device that replaces computers, tablets, phones, or other devices, or do you see it working alongside of these things?
We're really delving into like my opinion versus anything else. I do believe in an ecosystem of devices. I actually look around at the world around you. Even if you spend a lot of time on your phone, and maybe that's the primary thing that you use today, I don't know that you can say it's replaced every single other digital asset in the world. And just in the same way where you might spend more time in a particular medium, I think if you look at the world today and where technology is progressing, it's not consolidating down into one thing. It's actually expanding out into much more in the world. So, if I just look at trend, that's sort of where I imagine things will go. This thing will exist as part of an ecosystem, a digital ecosystem of many, many different things in the world. Because at the end of the day, think about it this way. When I make that thing into this thing, you are not going to be able to run every single processing compute activity on this thing. You're not even going to want to have sensors on this thing that look around you. There are probably going to be sensors and IoT instruments in the world that already exist in your world, but now can get connected to your experience, right? Like, I imagine a world where we're not talking about consolidating into one, we're actually talking about bifurcating into a ton of different things that do work together. And fundamentally, that working together is going to be the challenging part, because when you build one device, it's actually really easy to make it work seamlessly top to bottom. It's about bringing together this ecosystem of devices that's going to be more challenging. And I think that's going to be a next opportunity as well.
Hi, let me start my thing real quick. Would you hold that for a second? Okay, so I had two questions. One's a small question, one's a big question. The small question is, going back to the building with, let me press that right there, the point cloud building, you said it had really good fidelity, you're taking lots of captures, you're creating a global sort of map of points that represent a building. Does that improve the fidelity of LiDAR devices? Like, if you have multiple LiDAR captures, they create point clouds of buildings, but they don't always line up. They're off by inches or sometimes by feet. And that's the small question. The big question is, when you talk about environmental understanding, are you doing semantic segmentation on the environment? Are you saying, this is a floor, all the points here belong to this floor, this is a cup, all the points and all the pixels in space belong to this cup, and are the developers able to access the semantic understanding of the environment to say, okay, we're going to reskin the cup or put a sticker on the cup?
Okay, so for your first point, which is around, hey, can the technology we talked about in terms of mapping spaces, bringing together a bunch of segmented maps into a single map more accurately, how can that benefit something like a LiDAR scan of a space? When we built Generation 1, the head tracking system we built, the inside-out head tracking system we built was, top of the line, pretty much second to none. What we realized was that there was another segment that could really benefit from that, the VR segment. So what we did was actually we took the learnings that we had, the modules that we created, and we let the ecosystem build a set of VR devices that used our inside-out tracking modules as well as algorithms. Now, they didn't run on the holographic processing unit. They ran on your PC that you plugged your headset into, right? As we look forward, how many of you saw the announcements Microsoft made at NWC related to not the HoloLens 2, but some of the other things that we talked about, like, for example, Azure Kinect Dk? So the thing you might have noticed, and kind of forget how much we delved into this, the depth sensor module that is in Azure Kinect Dk is actually exactly the same depth sensor module that exists in HoloLens 2. So as we think about the set of technologies and IP that we create, it's not about just creating it only to put into this device. It's about thinking through, what does it actually take to create a mixed reality environment, a mixed reality ecosystem? And that's both the output part of it, but also the input part of it, right? Being able to understand and scan spaces, for example, is one. If we talk about a LiDAR system in particular, I figure somebody could go and take the head tracking system that we put into VR headsets and think about how would I, maybe put that into a LiDAR system. And then maybe you could use Azure Spatial Anchors to align all of those coordinate frames together, right? It's a possibility. I don't know that it's one the team has in particular explored, but it is a possibility. On your second point, which is around semantic segmentation and environment understanding, yes, so the deep neural network on the device actually contributes to that and does do the actual scene segmentation, semantic segmentation of the world. This is an area where, again, finite compute resources on the edge, we have to go define and determine what granularity, what classes of objects we want to go and truly segment and understand. So it is an affordance provided to developers. This is an area that we're still doing more investigation and research and feedback from the community about what does make sense and what is important.
Hey, Charlie. So one question regarding, I would like to get your opinion on what are the use cases you're seeing that are a great fit for HoloLens and the industries that are receptive and they want to build applications. And second follow-up question is, so Microsoft also has the VR headset, and we got actually at one of the meetups here, so I have it sitting at home and many of us have it.
Cool.
Now, what is the use case for building apps for that versus for HoloLens? And what's the Microsoft strategy on that, those two things?
Okay. We're now diving further and further into my opinion, so please take this with a grain of salt. Okay, the first one is actually less my opinion. You talked about what industries, what segments, what opportunities exist. We've seen particular strength and opportunity in architecture and construction. We've seen particular strength in discrete manufacturing, automotive and aerospace, as well as healthcare. Now, if you look across these and you say, those sound like very different industries and sectors, the thing that actually ties the opportunity across all of these is primarily that we're bringing capability and technology and data to a set of workers that historically really haven't been well served by technology. And these are what we call the first line workers. They're also sometimes called, field workers or task workers. I imagine that for the majority of the people in this room, we're all what we would call information workers. We for the most part, sit in front of a desk, and there's a computer, and lots of technology, and the world's our oyster. But for a lot of these folks who are out there, I remember talking with one of our partners, and they relayed a story to me about a large highway infrastructure project. And they said, you get frustrated at the technology you use in your office day to day. These guys have printed out 8 by 11 sheets of paper of the entire, 100-mile-long highway infrastructure project in their mobile command center, and they've pasted it painstakingly up on the wall of this command center, and they've highlighted with markers which segments were being worked on by which crews that particular day. And the next day, post up a new set of pages, and then highlight the next set of work activities for that day. And if you look across these industries, what you'll notice is that where we can deliver the most value, you asked, hey, where is the opportunity? Why should I bother building for this? Is because in those industries, particularly as the workforce is starting to age, there's so much opportunity to deliver technology and capabilities that are, the younger workforce that are coming in especially are picking up. And actually not just picking up, but almost expect. People who are growing up with smartphones is the thing that they, this is totally normal. This is how the world operates. When they get into those kinds of environments, it's like an alien landscape to them. They're trying to figure out, what am I doing with this piece of paper, right? I got to use a pen and pencil to check off a task that I did. And so those are the types of environments and scenarios where we see a ton of value. And if you go look across those industries, you'll see that the majority of the people who work in those industries are what we call these first-line workers. The workflows and the tasks that they're doing are typically pen and paper checklist type of activities. The types of work that they're doing is so tremendously complex, especially as technology is advancing more quickly around them, that they need the help and support that we can go and provide to empower them to achieve what they actually, what is their potential. So I would say those industries, but specifically sort of that sort of task worker type of scenario workflow. Oh, the VR in the air run. Yes, I mean, we care a lot about providing as consistent of possible development platform across the two so that you can share common code, common assets between these endpoints. But this one goes back to the right tool for the job, right? You know, if you're designing an experience that is about, you know, the highest fidelity, immersive experience, you know, a VR headset is still second to none for those types of, you know, context where you need spatial understanding, but at the highest fidelity. You're likely not going to wear a VR headset if you're that construction worker working on the highway project, right? So this is truly just right tool for the job, but we want to provide as many of the common affordances as possible so that you can transition between these. Like as an example, in our first party teams, the Dynamics 365 layout team, they've really thought about, you know, what parts of the activity workflow make sense where I'm on site in a physical environment and an AR experience makes a lot of sense versus I'm a designer and I may not always have physical access to that space. Well, I want to be able to recreate it in a pure digital environment, so I'm going to build a VR experience for that. But when you tie that together, they can share resources, they can share data amongst those two applications, but they really create the workflow pieces that make sense at each of those ends.
Hi, thanks for the talk, and I have two questions. First question is that you mentioned about comfort as one of the pillars. So my question is that how much time can the user use this? You know, in the typical form, you know, maybe look at the eye constraint and then also the battery power. How long can they really use so that we can figure out the project that can last through that task? Secondly, I wonder, you mentioned a little bit about VR mixed with the XR. So how, is there something like an emulator so that we can use it so that people that's not really always using this, but can using something light to create some kind of simulation or something? And on the side note, I also want to mention something about the experience, because recently I visited Bruce Lee's exhibition. And he talked about how he started 50-something years ago. He has a dream, and he keep following dream. And then when he teach people the Kung Fu, he said, don't follow everything that I'm doing. Create your own. This is a philosophy. So I feel that your team is very similar to creating something brand new. Now, can you show us the real world map? Maybe not. But you give us a tool, and then we can use the tool to create something great, and then help other people. I think that's what I feel very strongly about your talk today, so I want to kind of like share that.
Cool, thanks. I'll pretend I'm Bruce Lee the next time I give this talk or something. So let's talk about the point that is relatively straightforward to address the emulator. So we haven't, I don't think we've published it yet, but in the very near future we will actually publish an emulator so that even if you're not using the device itself, you can go and experience a lot of the capabilities of the device, including how do I model input for, like, you know, fully articulated hand tracking. So we've built a lot of that capability in as well already. So very soon you will be able to see that. If I recall correctly, build is coming up relatively shortly, so maybe or maybe not it'll be associated with that. The first point that you asked about, what was the first point you asked about? Comfort, yeah, sorry. Sorry. On comfort, you know, when we presented this at MWC this year, we talked about it being 3 times more comfortable than Generation 1. That was actually a measure in our labs of wearable comfort, the duration of comfort. There's actually, so the team actually has like 7 or 8 different principles and pillars around comfort. Like the team really loves pillars and principles apparently, so we all create them for every single aspect of the product. But there's like 7 or 8 different ones. You know, anything from, you know, head pressure, I talked about the brow pad, thermal comfort because it is a face computer, so like, you know, it generates thermals on your head. You know, the size that we, you know, of head circumference that we support, all of these different things. But ultimately, this all gets bundled up into, you know, one core metric that is probably the most end user understandable, which is around how long can you go wear this device. This is a metric that honestly varies across people, right? You know, depending on, you know, different demographics, whether you're young, whether you're old. there are infinite many different permutations and variables that result from this. So when we say 3 times the comfort, it really is about going from generation 1 to generation 2 and what you should expect relative to it. So it's hard for me to give you a precise, you specifically will, be comfortable for XYZ hours. What we've seen, as a median, let's say, is that we've tested this out to beyond 2 hours. And we've seen that people are fine and comfortable in the experience. Where that exactly trails off and where people start, being like, hey, you know what, I could do without this. We haven't yet even exceeded that. But again, it goes back to the very particulars of the specific human being. And that's sort of the thing about wearables, right? It's so unique and different for each human that makes it hard to provide you that precise number. Oh yeah, and the battery life will last more than 2 hours as well, for sure, yeah.
These are all excellent questions, and in fact, a lot of questions that you're asking tonight are what the global developer community want to hear answers to, so we thank you. Given Charlie's been on stage for quite some time now, we have time for 2 more questions, one from this gentleman, and then one more, and then if we take it off, and then you can maybe network.
Okay.
Yeah, you talked quite a bit about how you focused with HoloLens 2 on the headset tracking precision and latency, and you also talked about how it would integrate with devices like Kinect for Azure with spatial mapping. For a lot of tasks, there's a lot of concern about tracking input for hands and other body parts or controllers or devices like that, specifically reliability, latency, and precision. And I was wondering how you if there's any plans to support like Kinect for Azure for hand tracking, integrated with an active HoloLens device, whether you have support or you're planning support for motion controllers, things of that nature. Yeah,
so I could talk about the motion controllers just briefly. This is an area of active investigation. A lot of these trade-offs that we make and design decisions that we make go back to the core customer sets that we are supporting and we've seen opportunities with. So as I mentioned, a lot of the customers that we're working with are these task workers, first-line workers. And so their hands are oftentimes actually occupied by the tasks that they go and do. So we haven't seen a strong signal back yet about specifically that, we really want a controller. But if you have particular use cases and scenarios that you're really interested in, I'd be more than happy to hear them.
Yeah, a lot about hand tracking because in a lot of existing solutions, when you have your hand occluded from the headset directly or you move your hands quickly, there can be a lot of issues. So having extra cameras, having additional processing power that you can quickly access to improve the tracking.
Yeah, so this ties back to the Azure Kinect Dk. So as if I recall correctly, the inbox or shipping, the announced capabilities that it will provide are things like body skeletal tracking, object dimensioning and things like that. So the team has not written a hand tracking component, I think, just out of the box. But we provide, as part of the Azure Kinect Dk, the SDK itself, we do provide the full depth map of, whatever you happen to be pointed at. So as a developer, you could absolutely go create those algorithms and, hand tracking algorithms, for example. So that's a possibility. And in fact, like the depth map that is generated by it is very similar to the one that's generated here, although this is obviously internal to the holographic processing unit that we use to go and compute that. But the capability is there for you.
Thanks for coming, Charlie. My question is regarding Community California students adopting this technology early and really providing them not only the opportunity to be exposed and access it, but be part of the development team for the 3rd generation or future last mile edge development projects that you guys have planned or want to find partners with.
Is this like you want to join the team kind of question?
Actually a continuation of IDEO challenge for California's statewide online community college program.
I can't say I'm really familiar with
It's,
what that
it's
is, sorry.
Only 3 big ideas, so just went to the last phase and we received $5,000. We want to work with Microsoft as well as other tech partners in order to provide the best education for community college students.
Got it. Yeah, I mean, look, we work with a number of different education partners and providers already. Education is one of the, I would say, up and coming, like, I named a number of key industries. Education is probably the next one on the list, and we've seen, especially in high-end spatial, contextual types of concepts, we've seen a ton of value in this in terms of medical training, like CAE produced a nurse practitioners training solution, and they're seeing a lot of value in those types of experiences. So we do totally work with a bunch of education providers and education initiatives. I would say this is probably one where I can direct you to some of our partner program type activities is probably the best way to go and integrate. And then of course you can always provide us feedback in terms of what you would like to see in the device, the core platform, services that would help you accomplish what your vision is.
Thank you so much, Charlie. You were on stage for so much longer. We super appreciate it. I will say, just in closing, I know you guys want to network, you want to hang out with each other and eat more pizza. This whole thing is available on YouTube. So actually a whole community joined us online outside of those in this room. So if you guys want to revisit the questions, rewatch it, share it, this is the link. Thank you so much, Anthony, for recording this and streaming it for us. Another thing I will say is, it's quite impressive that this device is here. We weren't sure if Charlie was going to bring one down from the mothership in Redmond, but this device has basically only been at Mobile World Congress for the announce moments and then in secret meeting rooms. So it's pretty cool that it's here at this meetup first. And I guarantee you, as strategic as an investment the Bay Area, San Francisco is, we will be one of the first places to receive these HoloLens 2 devices for you guys to tinker with and develop on and build with. So very, very exciting. We have so many more exciting guests like Charlie to bring down on this stage. He's just one, he's very important, but he's one of like 1,500 people who work for Alex Kipman in mixed reality and AI. And then also a much larger roster of Microsoft people who work and touch the mixed reality products. For example, I just got a note from our head of mixed reality device sales, Mark Day, who's flying in for our June version of this meetup. So he's the guy who's going and selling those devices to customers. So I heard some great questions tonight already that were touching upon customer use cases and ROI. Come back in June. We're going to get the right guy to answer those questions for you guys. And thank you again so much for coming. Definitely network. And take advantage of all the Microsoft folks who are in the room, who are here to talk to you. And please take pizza. We have so much extra pizza. And I don't want pizza for breakfast tomorrow. Thank you, guys.